In this video, we will continue graphing sine and cosine with changes in amplitude, period, phase shift, and vertical shift. First, we should find these four values. The amplitude comes from the a value, which is going to be the coefficient way out in the very front. There's no number there. That means it is an invisible 1. So the amplitude is 1. Be aware that the amplitude is always positive. So even if this were a negative, I would still put positive 1. Next, the period. Normally, the period is 2 pi, except if there is a b value. So this number in the front, that's the a value. This number in front of the x is called the b value. And the period is 2 pi divided by the b value. Well, in this case, that b value is 3. So the period is 2 pi over 3. Let's write that down. So 2 pi over 3. Time to talk about the phase shift. The phase shift is a number that's being subtracted from the x value inside of parentheses. So if I had parentheses right here, the phase shift would be 2. However, there are no parentheses. That means that this minus 2 is not inside the function at all. In other words, this is simply the sine of 3x. The minus 2 is outside of the function. So that's going to come up in a moment as the vertical shift. So this minus 2 is the reason why the vertical shift is down 2. But there is no phase shift, so we will just put none. Because inside of the parentheses, there's nothing that's being added or subtracted with the x. So normally we put our first mark on the number line at the phase shift. Since there is no phase shift, our first mark will be 0, which is also where the y-axis belongs. So we might as well go ahead and graph the y-axis. So the y-axis will be our first mark. So here's the y-axis right here. All right, that's counting as our first mark. Let's put 4 additional marks as equally spaced as we can. So this is going to be 1, 2, 3, and 4. I put 4 additional marks because each one represents 1/4 of the period. We should be able to label these values by adding a quarter of the period. But what is the quarter period? Well, the quarter period is going to be the period divided by 4. So I'm going to take the period of 2 pi over 3, and I need to divide this by 4. But look, if you want to divide a fraction by 4, all you have to do is put 4 in the denominator. Boom, now I divided by 4. So the quarter period will be 2 pi over 12. Then this reduces down to pi over 6. So I'm just going to record that over here. So the quarter period, never forget, is pi over 6 for the rest of this problem. So if I take 0 and I add a quarter period, if I add pi over 6, then of course I'm going to get pi over 6 for this first mark. Now, I'm going to keep adding quarter periods. So if I take this pi over 6 and I add another quarter period, another pi over 6, that's going to give me 2 pi over 6. But that reduces down to pi over 3. What if I add another pi over 6? Well, that'll give me 3 pi over 6. And then that reduces down to pi over 2. What if I add another quarter period, another pi over 6? That will give me 4 pi over 6, which reduces down to 2 pi over 3. So that will be the value at my final mark. Now we have the x-axis completely labeled. Now let's deal with the y-axis. Let's start with the midline. Remember, we have this vertical shift down 2 because of the -2. So let's go ahead and go down 2. So here we have 1, 2. So here's -2. This is going to be my midline, my new midline. Normally the x-axis would be the midline, but if you have a vertical shift, the midline drops by that amount. I'm going to put a guideline here to help me make a nice straight midline. All right, you should show your midline as a dotted line. So I'm going to go ahead and do that now. Here's my midline. Now let's consider the amplitude so we can see what will be the high and low. The amplitude is 1. That means the graph will go 1 above and 1 below the midline. So I already have a mark 1 above the midline. Let me go ahead and label it. So that's -1. Let's put another mark 1 unit below the midline. That would be -3. The next line I draw is going to be optional. I like to put a yellow guideline just to help me better see where my highs and lows will be. But you don't have to do this. Okay, time to graph. This is a sine function that we're graphing. We always start at the phase shift. In this case, there was no phase shift, so that means we're going to start at 0. For the sine function, you begin on the midline. So I'm starting at 0 because there's no phase shift. Sine function starts at the midline and goes up. So a quarter period later, the sine function will be at its high, and then it falls back to the midline, and then it falls to its lowest point, and then back to the midline. So this graph is going to look something like this. And that's how you do it. For problem number 18, the amplitude, which is the A value, is going to be 1. Because there's no number here, that's an invisible 1. Amplitude is always positive. Even if this had been negative, I would have put +1 for amplitude. What about the period? Well, the period is going to be 2 pi divided by the b value. The b value is the coefficient of the x here. But there is no b value, or you could say the b value is 1. Either way, that just leaves the period at 2 pi, just like the parent function. What about the phase shift? The phase shift is going to come from this number right here that's being subtracted from the x value inside parentheses. This is called the h value, by the way, but it is the phase shift, which is simply 3 pi over 2. Notice that it is always the opposite sign from this. This is -3 pi over 2, so the phase shift is +3 pi over 2. Had this been +3 pi over 2, I would be writing -3 pi over 2. The vertical shift comes from this value on the very end, which is called the k value, and it works just like you would think. A -1 is a shift down 1. Next, we want to label the x-axis. Always start at the phase shift. So I'm going to put my first mark right here, and I'm going to label it 3 pi over 2. Go ahead and put 4 more marks equally spaced. So 1, 2, 3, 4. I put 4 additional marks because each one represents a quarter of the period. So I should be able to label them by repeatedly adding a quarter of the period. Well, if the period is 2 pi, then a quarter of the period, QP, should be 2 pi divided by 4. This reduces down to pi over 2. So that's my quarter period. So I'm going to take my initial phase shift, 3 pi over 2, and I'm going to add a quarter period. I'm going to add pi over 2. So that will give me 4 pi over 2. But this reduces down to 2 pi. So that will be the next value. So now I add another quarter period, another pi over 2. But this makes 5 pi over 2. So that'll be the next value. And now I add another quarter period. And this makes 6 pi over 2, which simplifies to 3 pi. And finally, I add another quarter period, which gives me 7 pi over 2. Great, the x-axis is now completely labeled. Okay, I didn't really leave room for the y-axis, so I should have left a little more space over here for the y-axis. I apologize for that, leading you astray. I'm going to cheat because this is digital and just slide this over a bit. So always leave yourself a little room for the y-axis. The y-axis always belongs at 0, and so I have my first value is positive, so I know the y-axis will be over here to the left. So I have now created space for the y-axis, and let's draw it. Okay, so my y-axis will be over here somewhere, something like this. All right, the midline is going to be down 1 unit. So I'm going to go down 1 unit and put a mark. This is going to be the midline here at -1. This is going to be a little bit messy because it's going to travel right through my values here. I'm going to draw a guideline so I can make a nice straight midline. All right, so here's my midline. And this is supposed to be dotted. So don't go thinking that these are negatives or anything. This is just my dotted line, midline, that's all. Nothing to see here, folks. Now the amplitude will tell us how far above and below the midline the graph goes. The amplitude is 1, which means the graph will go 1 above and 1 below the midline. Well, 1 above the midline, we're at 0. If I go 1 below the midline, so I'm going to need another mark here, I'm going to be here at -2. Always label the y-axis. At the very least, I should see 3 values on your y-axis. I should see the midline labeled, your high value labeled, and your low value labeled at a minimum. So I already have the x-axis showing where my high values will be. I'm going to put an optional guideline in yellow, showing my low points. All right, just helps me keep everything nice and neat. So our first point will always be at the phase shift. So remember, the phase shift is 3 pi over 2. I'm not starting at the y-axis. I'm going to start at 3 pi over 2. This is a cosine function. A cosine function will start at its highest value. So that should be right here above the midline. And then a quarter period later, it falls to the midline. Then it falls to its lowest value. then it returns to the midline and ends at its highest value. So this cosine function should look something like this. All right, something like that. All right, we've got one more graph to do on this video, problem number 19. The amplitude is going to be 1 again. The amplitude comes from the A value, which is this invisible 1 right here in the front. Please remember the amplitude is always positive. Even if this were a negative, I would still put a positive right here for the amplitude. How about the period? The period is 2 pi divided by the B value. The B value is right here in front of the X. I don't see a number here. That means it is a 1. That means that the period will simply be 2 pi. So let's go ahead and write that down. So the period is 2 pi because there really is no B value. What about the phase shift? The phase shift is going to come from this H value. It's always going to be the opposite sign that you see here. So because I have plus 5 pi over 6, the phase shift will be negative 5 pi over 6. And finally, the vertical shift will come from this K value. And it works just like you would think. A plus 4 will be up 4. So let's start by labeling the x-axis. Always start with your phase shift. So I'm going to put my first mark down, and I will label it negative 5 pi over 6, because that is the phase shift. Now put 4 more equally spaced marks on your number line. I put 4 marks because each mark represents a quarter of the period. If I want to find the value at each mark, I will add a quarter period over and over again. So what is a quarter of the period? Well, a quarter period will be the period divided by 4. So the period is 2 pi, so the quarter period will be 2 pi divided by 4. So that's going to be pi over 2. To find each of these values, I'm going to start with the phase shift of negative 5 pi over 6. And I'm going to add this quarter period. I'm going to add pi over 2. Except, wait a minute, I need like denominators. So imagine that I were to multiply by 3 over 3. You can see that this quarter period would be the same thing as 3 pi over 6. Well, negative 5 pi over 6 plus 3 pi over 6 is going to be negative 2 pi over 6. So the next value will be negative 2 pi over 6. Well, wait a minute. This is going to reduce to negative pi over 3. If I add another quarter period, so another 3 pi over 6, this is going to equal 1 pi over 6, or simply pi over 6. How about if I add another quarter period? Okay, I'm adding another 3 pi over 6, so that'll be 4 pi over 6, which reduces to 2 pi over 3. If I add one more quarter period, plus 3 pi over 6 makes 7 pi over 6. So that'll be the final value. Now we have the entire x-axis all labeled. That means it's time for the y-axis. Well, where will the y-axis be? I see that I've got a negative value at negative pi over 3, followed by a positive value at pi over 6. The y-axis should be in between these two. So I'm going to go ahead and put my y-axis in there. All right, let's just put it anywhere in here is fine. As we do our graph though, please be aware that the y-axis is not one of the 5 marks. It's just here for us to record the midline and the amplitude. So the midline is at 4. So I'm going to go ahead and go up 4. Okay, so this would be 1, 2, 3, 4. So here is the midline. In fact, let's go ahead and draw a guideline. I'm going to draw a guideline because I want to keep my midline straight. So I'm going to draw a line right here at 4. And we really should record our midline as a dotted line, so I'm going to do that now. Now, what about the amplitude? Remember that the amplitude is 1. That means the high and low of the graph will be 1 above and 1 below the midline. If I go 1 above the midline, I will be at 5. If I go 1 below the midline, I will be at 3. You need to label at least these 3 y values, the low, the middle, and the high. Now, the next lines I'm going to draw are optional. I like to draw yellow guidelines at my highs and lows. So I'm going to have this yellow guideline right here at the high value mark. And I'm going to have a yellow line right here at the low value mark. Okay, I missed it a tiny bit. But you know what? I can just move it. So the yellow lines represent the highs and lows based on the amplitude. So where was I? Where was I? It's time for me to graph the 5 key points. Always start at the phase shift, the first mark that you put. The sine function will begin on the midline. So my first dot, my first point will go right here at the phase shift on the midline. And then from there, the sine function goes up and down and back. So a quarter period over, the function will be at its highest point. Another quarter period goes by and we're back at the midline. A quarter period later, the sine will be at its low. And finally, a quarter period later, the sine function will be back at the midline. Notice how I ignored the y-axis just then. It's not one of the 5 marks. So I go straight from negative pi over 3 to pi over 6. A common mistake is to try to put a dot on the y-axis. That would be wrong. So the function is going to look something like this. So that's it, guys. That is how you graph a sine function or a cosine function with changes in amplitude, period, phase shift, or vertical shift.